Algebra 1 skills number 48, parameters of linear and exponential functions. So what exactly is a parameter? It's a measurable factor that sets conditions for a particular mathematical system. It's the variables that makes linear be linear or exponential be exponential, for example. So looking at some linear, first of all, what are the linear parameters? We're going to take it from the y equals mx plus b perspective. Well, here your parameters would be the slope, which is your m, and your y-intercept, which is your b. So knowing that something's linear, you should be able to pick out or work with or discuss what's the slope of that particular situation, what's the y-intercept of that particular situation. Okay, so here's some examples. Find the linear parameters for the given table. Okay, so we see that we know it's linear because you're going up by the same amount each time. Well, what you're going up by is what we call the slope. So here you can tell easily that you're going up by 5. That's your m value. And your y-intercept is what you start with. It's kind of like term 0. Okay, so that would be 7 in this case. So instead of saying y equals mx plus b, we can now say y equals 5x plus 7. Again, slope is what you're going up by, and y-intercept is what you start with. It's like term 0. Okay, for a second example, we can do it from a graph. Okay, so here's a graph. We know that linear systems graph lines. Well, the slope is, you can count that off. So if you just pick a point that you know it goes through, we're going up 2 units and over 1. You can do it again here. Up 2 units and over 1. Up 2 units over 1. So your slope is 2 over 1, or 2. Your y-intercept, from a graphical standpoint, is where it crosses the y-axis. So that would be -1 in this case. So instead of y equals mx plus b, we can say y equals 2x minus 1. Again, a linear situation, the parameters are the numbers that sort of have sense in this situation. From a word problem perspective, an electrician charges $100 for a house call and then charges $50 per hour. Well, here your slope would be 50. Again, that's what changes each hour. Each hour he or she works, he or she earns an additional $50. The y-intercept here is what you have to pay before any work is done. So in this case, it's 100. So we have 50x plus 100. Note that you could put in 1 for x, and that would tell you how much money you've spent. 1 hour would cost you $150 in this case. For your exponential parameters, we're going to use this situation, y equals a times b to the x, where a is your original amount. It's kind of like term 0 again, and b is what you're multiplying by. Okay. Now we also talked about this from a geometric sequence standpoint, which you see in x minus 1 exponent. So you have to be careful in distinguishing between those two, and we'll talk about that with our examples. So example 4, here's a table. Again, it's clearly exponential. You're multiplying by 2 each time. So a is what you start with. Okay, so you start with, or term 0, you can think of it as 8. And what you're multiplying by is the 2. If it's not clear what you're multiplying by, you would divide any number by the previous number. Okay, what's called our common ratio from a geometric sequence standpoint. For the a times b to the x standpoint, this sequence or this equation would match this table. Be careful, you could also use this one where 16 is term 1. So you have to distinguish. If you're using term 0, the exponent is x. If you're using term 1, the exponent is x minus 1. But note, in either case, if I plug any of these x's into either one, I get the corresponding y. For example, if I use this last row 3, plug a 3 in here, and use your calculator if you need to. 2 to the third power is 8. 8 times 8 is 64. If you put a 3 in here, 3 minus 1 is 2. 2 to the second power is 4. 4 times 16 is also 64. So either one could work. So you might want to be sure you know the difference between these two and the fact that these two actually are the same situation. Example 5 from a graph. Find the exponential parameters for the given graph. So note the shape here. The exponential graph is flat on one side, steep on the other. And these points kind of make your own little table again. And a is 4. Again, if you use the exponent x, you'd use term 0. So that you can see it's 4. Now to get from 4 to 2, you're going down. And what causes that for an exponential is when you multiply by a number less than 1. Okay, so if you divide 2 by 4, you get 1/2. You're multiplying by 1/2 each time. that would generate this sequence. I'm not going to show the other one here just for lack of space, but you could also use the 2 in this position and let that be x minus 1. That would work as well. A sixth example, a third one here for exponentials. What about a word problem? A viral video has 100 views on a given day and triples in views each day. Okay. Well, we can think of 100 as kind of day 0 is where you start. And since you're tripling, that naturally would be 3. You're multiplying by 3 each time. And again, talking about that distinction we had already discussed, you could use this or this. This would be if you let 100 be day 0, you're tripling each day, and this is your sequence. Or if you want to use this as day 1 or the day after 100, okay, triple 100 to get 300, have the same base and let it be x minus 1. Either one would work. Parameters of linear and exponential situations.